Hi, welcome to the Sigma Cat. Today we will be discussing about functions and relations. So a relation is any set of ordered pair. So when we say an ordered pair, we have x, y. So it is said that the set of all first coordinates is called the domain of the relation, and the set of all second coordinates is called the range of the relation. So this one is called this x, the values for x is called the domain, and y is called the range. So a function, on the other hand, is a relation where each element, note that if where each element in the domain is related to only one value in the range. So a function is a relation. It is stated by some rule that a relation is a function if the domain is related to only one value in the range. We will show some examples and representations to describe a function. For now, let us know that this is true, and that it is true that relation, I mean all function, all functions are relations. But not all relations are functions. Now, a function and a relation can be represented through sets of ordered pairs. Say that we have a set of ordered pairs A. The set is enclosed in a curly bracket. We have, let's say, 0, 1 as our first ordered pair. Then we have 1, 2, 2, 3. So this set of ordered pairs is called a function. This relation is a function. Why? Because it satisfies the rule of functions, which says that a function is a set of ordered pairs such that no two ordered pairs have the same x value. Notice that the x values for this set of ordered pairs are unique, so no x value is repeated. So we have 0, 1, 2, 0, 1, and 2. So another example, we have, let's say, B as a set of ordered pair. We have 0, 0, 1, 1, 1, and negative 1. Notice that the x values are not unique. We have 1 in the second and third ordered pair repeated. So this one is not a function. So say that we have C 0, 3, 1, 2, 2, 2. So the x values are unique, But some might ask that how about if the y values are repeated? Like for this case, we have 2 and 2 in the range. So we have some cases called on 1 to 1 and on 2. So this one is still a function, okay? And this is a function that is on 2. I will not be discussing the types of function here, two types of functions here, and I will discuss it in another video. So now that we know how to identify if a relation is a function or not a function through the set of ordered pairs, now let's go ahead and proceed to another representation. So we have representation of a function through mappings. So let's say we have x and y. It's the domain and the range. So we have values like 1, and let's start with 0, 1, 2, 3, 4. For the domain, these are the elements of the domain. And for the y, we have 1, 2, 3, 4, 5. And we have connectors 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So this mapping is a function. Notice that each element of x, or each element in the domain, has only one corresponding value in y, or in the range. So this mapping can be written in a set of ordered pair. We have 0 to 1, 1 to 2, 2, 3, 3, 4, and 4, 5. So let's look at another example. We have, let's say, have another xy. We can use the same values. We have 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. And change the connectors. Say we have 0, 1, 0 to 1, 1 to 2, 1 to 3, 2 to 4, 3 to 4, 4 to 5. So if you look this one closely, we notice that 1 has 2 corresponding values in y. So instantly, this mapping is not a function. Okay? So this is not a function because 1 has 2 corresponding y values. So this mapping, this relation can also be written in the set of ordered pairs form. So we have 0, 1, 1, 2, 1, 3, 2, 4, 3, 4, and 4, 5. The number of connectors is also the number of our set of ordered pairs. So we have 1, 2, 3, 4, 5, 6 connectors. So we expect the number of ordered pair. We have 1, 2, 3, 4, 5, and 6. So identifying functions and not non-functions through graphs. So to identify if a given relation is a function, or not. For graphs, we use the vertical line test. So it states that the graph of a function intersects the vertical line or the y-axis at most once. So it is said that a graph is a function if it intersects or does not or may not intersect the vertical line. So if it intersects the vertical line or the y-axis, it should only intersect once. So to illustrate, let's use some examples. Say we have a graph, a linear graph more specifically. So again, this is the vertical line is the y-axis and the horizontal line is the x-axis. So say if we have a line. So this blue line is a function because it intersects the vertical line only once. So say if we have a parabola facing upward and looks like this. This one is a function. As I said before, it may or may not intersect the vertical line or the y-axis, but if it intersects the vertical line, it should only meet or crosses the line, the y-axis, only once. So this parabola facing upward is a function. For another example, we have, let's say we have a parabola facing downwards. So this one is a function. It's obviously a function because it only intersects the vertical line once. So what if we have a parabola facing to the right and it starts here? What if the parabola or the graph looks like this? So this one, this purple graph, is not a function. It's not a function since it intersects the vertical line twice. So I hope that's clear. And for the next part, we'll be identifying a function or just a relation through equations. So if the given relation is an equation, then any x can be plugged into the equation will yield exactly one y out of the equation. So in other words, if the degree of y is odd, then the equation is a function. So when you say odd, the y should be raised to the power of 1, 3, 5, and other odd numbers. So as an example, we have y equals x plus 1. This one is obviously a function since y is raised to the power or the degree is 1. What if we have x equal to y squared? This one is not a function since y is raised to 2 and 2 is even. Okay, so what if we have, let's say y cubed x to the 5 plus 1 over 3. This one is a function since y is raised to an odd number. Okay, that's how you look at equations and identify if it's a function or not. So as I have said before, any x that can be plugged in to the equation must yield exactly 1 y. So to do this, to achieve this, we must have a y that is raised to an odd number, or the degree of y should be odd.